Hi guys, in this video we continuously work on section 6-3. So please open your book to page 375. We are working on problem 2 together. Architecture. In the stained glass window design, the side of each small square is 5 inch. Find the perimeter of the window to the nearest tenth of an inch. Okay, so please look at the picture, guys. We have a rectangle, and then you're going to have one to three sections, so it's gonna be easier that we do 1, 2, 3, 4, and we have an overlapped 1, 2, 3, 4, right? It should be a little bit bigger, but let me do it again. Okay. Now we have continuously do this, and then extension. Okay, so we're having this type of shape. Now we're going to find out the perimeter of the window. So here, side of each small square, that should be square, guys. So that would be 5 inches. So these are all 5, 5, 5, 5, 5. You can find all the numbers. Now, I want you to get the length of perimeter, which is a length here, which is width. Okay? So in this situation, I need to look at the diagonal, right? Right here. Because this is the same as this length. That is going to be the diagonal of my one square. So please, let me take this square out. And then this would be the same length of here. So if I have a 3 diagonals, it will be exactly same as length, right? Samely, if you have a 2 of them, that would be width. So I have to find out that length. So as they said, each side is a 5. How do I get my diagonal, guys? You can apply to the Pythagorean theorem. What is the Pythagorean theorem? If you have if you have a right triangle, A, B, and C, then C squared equals A squared plus B squared. So your C would be square root of the sum of A squared plus B squared. This time I have a 5 and 5. 5 and 5, either one become A and B. So if you plug in there, 5 squared plus 5 squared. 5 squared is 25. So you would have a C equals radical 50. Since 5 squared is a perfect square number, how many do you have? 2 of them. So 5 radical 2. That would be the length of the diagonal. Now, how many do I have in here? 3 of them. So my length is going to be 3 times 5 radical 2, which is 15 radical 2 inches. Now my width is 2 of them. 2 times 5 square root of 2, that becomes 10 radical 2. Now what? You have to find out perimeter of this. What is the formula of the perimeter? Perimeter is a 2 times L plus 2 times W, so plug in the number. What do you have? 2 times 15 radical 2 plus 2 times 10 radical 2. Now what? 2 times 15, 30. Radical 2 plus 2 times 10, 20 radical 2. Since we have a same index and radicand, add them up. 50 radical 2. What is the unit? Inches. That is going to be the answer. So at this time, they said we need to round up to the nearest tenth. So please take out your calculator. 50 radical 2. So radical 2. Let me use my calculator here. So I have a radical 2. Where is my radical? Radical 2 and then you have times 50 with it. That would be 70.71. The question is round up to the nearest tenth. So my answer here is 70.71, but you're going to round down. So your answer would be 70.7. That is your final answer. Okay? Alright, now I need you guys to work on got it 2 by yourself. After that, please check your answer with me. Alright, so got it 2. What is the question? Find the perimeter of the window if the side of each small square is 6 inches. Everything is the same. So let me get my L, which is a 3 times 6 radical 2. That will be 18 radical 2. And width, which is a 2 times 6 radical 2. Guys, everything changed 5 into 6. That's it. And then that would be 12 radical 2. So now what? Your perimeter is 2 times L plus 2 times W, which is 2 times 18 radical 2 plus 2 times 12 radical 2, which is a 36 radical 2 plus 24 radical 2. 36 plus 24, that would be 60 radical 2. So please open your calculator again. I need to get a 60 radical 2, so this time I would, whoops, okay. So, you know, you have, yes, I'm going to delete, times 60, and I got an 84.85. So, 84.85, but you need to round up, 84.9 inches. That will be the answer. Okay? Alright, B. Describe a different sequence of steps which you could use to compute the perimeter of the window. Instead of doing it, what we can do. The length of the diagonal of a square of side 6 can be found using the Pythagorean theorem. That's what I, used, right? So, another way we can use the, special triangle, the ratio 1 and 1 and right equal 2. But, I don't think you guys learned before. So we can just stick with using the Pythagorean theorem in here, okay? So you can ignore the got it 2, B right now. All right, let's move on. So next question, page 376, problem 3. Simplifying before adding or subtracting. So in here, you have to you should simplify each expression so that you can find all the like radicals, which means you have to break up your given number 12 and then 75 into the prime factorization. So 12 is a 4 times 3, and 4 is a 2 times 3. So I can say radical 12 would be 2 squared and 3, and then you can do the 75 here. 75 is 25 times 3. 25 is a 5 times 5. 5 is squared times 3 and minus radical 3. Because, the process needed because we need to make the same radicand. So now, 2 squared can be simplified as a 2 radical 3, right? And 5 squared is perfect square number. 5 can be pulled out and leave 3 inside. Minus radical 3. Okay. Everything has an index 2 and the same radicand, which is 3. I can work with that. 2 plus 5 minus 1 this time, radical 3. What do you have? 2 plus 5 is 7 minus 1, 6, radical 3. That is the right answer. Okay? Alright, I need you guys to work on got it 3 now. Got it 3. What is the simplest form of the expression cube root of 250 plus cube root of 54 minus cube root of 16. Since they have the same index but all different radicand, I can work with it. So I'm going to do the prime factorization of a 250. 250, 25 times 10. 25 is 5 times 5, and then I do the 10 as a 5 times 2. So I may rewrite 250 with the cube root would be 5 cubed times 2. Let me expect that I'm going to have a 2 in the radicand. Now, 54. What number can go into 54? 2 can go into 54 since 54 is even number. Now 2 can go into 5 twice and you have a remainder 1 that become 14. Now 27. Oh, 27 is what? Perfect cubed number, which is the 3, right? So I can do 3 cube root of 3 cubed times 2. Now my last. Alright, so 16 here. 16 is a 4 times 4, and then a 4 would be 2 times 2, and 4 is 2 times 2, so I can make cube root of 16 as 2 cubed and 2. I did it on purpose because I wanted to make a perfect cube number. Now what? Simplify after that. So my first one, 5, could be go out. 5 cube root of a perfect cube of 2. Cube root of 2. Now 3 cube root of 2 minus 2 cube root of 2. So everything has 3 as an index and then 2 for the radicand. So you can work with it. 5 plus 3 minus 2. Cube root of 2. What is it? 6 cube root of 2. That is going to be the answer. Alright, now we are going to working on the problem 4. Alright, wait a second. Okay, I did the 2 questions. Alright, I'm going to stop this video right now. So we are going to see the next video, guys. Bye.